All right, students, today we are going to talk about something called proportionality. First, I want you to take a moment and pause the video and do our Be Curious section here. So make a note, maybe just some bullet points of how each of these prices for go-karts and laser tags, how they are similar and how they are different. Go ahead and pause the video, write 1 or 2 bullet points, and then come back and let's see what you got. All right, hopefully some of the things you notice is first what they have in common is that for ride 1 or for game 1, it's the same price, $8 for each. Then you might have noticed as well that how they are different, so the price changes for 2 rides or 2 games, and then for 3 as well, increasing more for the laser tag per game than compared to the rides for go-karts. So like I said earlier, we're going to talk about something called proportionality today. So as we can see these two here, they are not proportional to each other because it's not increasing the same amount of money for each game or ride. So we're going to take a look at that more down below. All right, down below here for our first example, we are looking at trail mix. It says a local fitness store sells family-sized packs of trail mix that contain the amount of peanuts and raisins shown. They also sell a single pack with 3 ounces of raisins and 2 ounces of peanuts, and an office pack with 18 ounces of raisins and 12 ounces of peanuts. So our big question that we need to figure out is how do the amounts of raisins and peanuts in each pack compare? First thing I would suggest that we do here is we color code the information that we're given. So let's first start with the single pack. I'm going to highlight this in pink. So for a single pack, we have 3 ounces of raisins and 2 ounces of peanuts. For the office pack, I'm going to highlight this in blue. So an office pack has 18 ounces of raisins and 12 ounces of peanuts. And then lastly, let's look at our sign for the family pack. I'm going to do this in red. So the family pack contains 12 ounces of raisins and 8 ounces of peanuts. All right, so let's now fill in our table. Again, I'm going to color code this to match up with the colors that we used above. So we'll start with the single pack. So the single pack has 3 ounces of raisins and it has 2 ounces of peanuts. So that's what we're going to fill in for our table for raisins and peanuts. Then for our ratio, we're going to do raisins on top of our fraction, peanuts on the bottom. So since raisins we had 3 ounces, I'm going to put a 3 on top. On the bottom we have 2 ounces of peanuts, 2 is going to go on the bottom. So that would be our ratio comparing raisins to peanuts in our single pack of trail mix. Okay, now let's take a look at the family pack. So that's what we did from the table in red. So I'm going to again write in red here just so we can kind of color code and keep things straight. So for raisins, we had 12 ounces of raisins in the family pack and 8 ounces of peanuts. So when we write our fraction, we're still going to use those numbers in red here. So we're going to write 12 over 8. And then we should always check when we have fractions to see if we can simplify, which we can here. If you're not sure what you can simplify by or what you can divide out, always look to see if there are even numbers. So we do have 2 even numbers here with 12 and 8. So we could start by dividing out 2, but the biggest number we can divide out of both 12 and 8 would be a 4. So that's what I'm going to do today. Divide out a 4 from the top and the bottom. So 12 divided by 4 is 3, and 8 divided by 4 is 2. So our ratio for raisins to peanuts for the family pack is also 3 over 2. Lastly, let's look at the office pack. So the office pack had 18 ounces of raisins and 12 ounces of peanuts in it. So we have our 18 and our 12 in those 2 columns. Again, let's write their ratio here, or our fraction. So raisins, which was 18, goes on top. The 12 for how many ounces of peanuts goes on the bottom. Once again, let's check to see if we can simplify, which we can here. So we got to think of what's the biggest number we can divide out of 18 and 12. Go ahead and think about that for a moment. Okay, hopefully you had a chance to think about it now. So the biggest number we can divide out of 18 and 12 would be 6. So when I do 18 divided by 6, I get 3. When I do 12 divided by 6, I get 2. So what do you notice about these 3 ratios? See that they all are the same. Okay, so whenever we have ratios that are constant with each other, that means that they form a constant of proportionality. Okay, when they form a constant proportionality and when the ratios are constant, this relationship we can call it proportional. Okay, so coming down to this question down here, let's think about this. It says, could you have instead used a ratio of ounces of peanuts to ounces of raisins to determine whether the relationship was proportional? So I want you to go ahead and pause the video here, Think about what that means and write down an answer for kind of what you're thinking, what you're brainstorming, and then come back and watch the video to see what our answer could be. All right, now that you've had a chance to think about that question, let's talk about it. So again, it said, could you have instead used the ratio ounces of peanuts to ounces of raisins to determine whether the relationship was proportional? So the answer is yes here. The reason why is if I would have flipped the order and done peanuts on top and raisins on the bottom, we would have had a ratio of 2 to 3 for each of these. But that's going to still be the same for every single one. For the single, the family, and the office packs would all have a ratio of peanuts to raisins as 2/3. So because those ratios are all still constant, this is still a proportional relationship. All right, now let's try some practice questions for today. So for exercises 1 through 3, you're going to use the information from the table and your knowledge of proportional reasoning to answer the questions. So here it says the number of each color of balloons in 2 different sizes of balloon bouquets are shown. So we have small bouquets and large bouquets. Within each of those bouquets, we have 4 different colors, so blue, red, green, and yellow. Okay, so the first question asks what ratio compares the number of blue balloons to the number of red balloons in a small bouquet and then in a large bouquet. So let's first start with our small bouquet here. Okay, when we look at this, we are comparing the number of blue balloons to the number of red balloons. So in that small bouquet, the number of blue balloons would be 8, so we're going to put that on top of our fraction. And then the number of red balloons is 14 for our small bouquet. Okay, so here we have our ratio to start off with. Let's go ahead and simplify. Again, always when we have a fraction, let's see if we can simplify it. Here, the biggest number we can divide out of 8 and 14 would be 2. Okay, so when we do that, 8 divided by 2 is 4, and 14 divided by 2 is 7. Okay, now let's take a moment and find our ratio for our large bouquet. I want you to actually try this yourself first before we do it together. So again, go ahead and pause the video here. Take a moment, figure out the number of balloons, blue balloons compared to the number of red balloons we have for our large bouquet, and then come back and let's check to see if you got it correct. All right, hopefully you've had a chance to check it. So now let's try it together. So for the large bouquet, we have 24 blue balloons, and that is compared with the 28 red balloons. Okay, we can simplify this fraction again. So I can divide both 24 and 28. The biggest number would be 4 from both these. So 24 divided by 4 is 6, and 28 divided by 4 is 7. Okay, so that is our ratio. For small, we have a 4 to 7 ratio of blue balloons to red balloons. For the large bouquet, we have a ratio of 6 to 7. Okay, so now let's look at question number 2. So it says, is the relationship between the number of blue balloons and the number of red balloons in each bouquet proportional, and explain your reasoning. Okay, so in order for the relationship to be proportional, we need to look at the ratios and if they are the same. So here we had a ratio of the small bouquet of 4/7, and then for the large bouquet, 6/7. So because they have different fractions or different ratios, these ones are not proportional. Okay, make sure you add a little explanation there. Again, we said it is not proportional because those ratios are not the same or not equivalent. Now let's take a look at question number 3. So it asks, is the relationship between the number of blue balloons and the number of yellow balloons in each size bouquet proportional? And explain your reasoning. So this one I want you to try first from start to finish. So go ahead and pause the video. Go try this one on your own. Again, you're looking at blue balloons compared to yellow balloons in each size, so both small and large bouquets. Take a moment, pause the video, try number 3, and then come back and let's check to see if you got it correct. All right, now that you've had a chance to try this, let's talk about number 3. So first, let's start with the small bouquet. Okay, we are looking at blue balloons compared to the number of yellow balloons. So for blue, we had 8. For yellow, we have 10. We can divide both of these by 2. When we do that, we get 4/5. Now let's look at the large bouquets. For blue, for the large, we have 24. For yellow, for the large, we have 30. Both of these, the biggest number we could divide out is a 6. So when I divide out the 6, on top we should get a 4, and on the bottom we get a 5. So by looking at these two ratios, we can determine that yes, this relationship is proportional because the ratios are equivalent. All right, that was the last question for today. You're going to go ahead and skip number 4. Go ahead and cross it off and go ahead and try your homework today. Remember to try your best on it. Come back and look at the examples that we did here in this video if you need to for a little refresher. But try your best on it, and then we will go over the answers tomorrow in class and go over any questions we have.